Lesson 2, simplifying rational expressions. All right, so we're ready to do lesson 2, and it's on simplifying. So we still have to state non-permissible values for all these questions as well, so that didn't go away. But now what we're trying to do is we're trying to take a rational expression, so something with something on the numerator, something in the denominator, and reduce them to make them more simple. That's all simplifying really is. Okay? So the steps for simplifying rational expressions is number 1, you're going to factor the numerator at the top and the denominator at the bottom. So the first thing you do is GCF them, or difference of squares them if you can. Then you're going to state non-permissible values at the bottom. So this time you actually have to do the top as well because we're going to be simplifying. And then we're going to cancel off what matches. And we're write what's left over. That's it. Okay? When 1 is the only common factor that's expressed, is in the expression, you know that you're simplified. So example 1, express the following rational expressions in simplified form, stating the non-permissible values as restrictions. All right. So we have 2x squared and we have 2x. See that? So those are separate. Those are not the same. We can't take out GCFs or anything like that because this is a monomial, and we haven't really done a monomial yet. Monomial just means that you don't have any positive or negative signs, any subtractions or additions or anything. Try and say monomial a whole bunch of times. It's really hard. Monomial, 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 monomial. Yeah, I'm bored, guys. Can you tell? All right. Okay. So, these are monomials. When you have monomials, great. What's great about them? You can't factor or GCF them. You go right to the step of putting them in brackets. So, remember when I said when things are multiplied together, you can just put them in brackets separately? So, we're going to have a 12 in separate brackets and an x squared in separate brackets. On the bottom, we're going to have a 2 and an x. That is it. Literally. Okay, that's our GCF difference of squares and stuff like that. That's it. So when we have monomials, we just first put them in brackets. No GCF, no difference of squares. Skip step 1. Step 2, state non-permissible values. So I have 2 brackets. I'm going to do the non-permissible values down over here. I don't know where I'm writing them. NPVs. I'm doing it over here. Okay. So we take the 2. And we say 2 cannot equal 0. And we're like, yeah, Lepp, we've done this 800 times. We get it. When it's a number, it's not an NPV. You're right. But this is 801. So that's correct, but it doesn't get me an NPV because it's just the number 2. And when it's just a number, it doesn't get me an NPV. And then I go x cannot equal 0. And then that one's done. Now, some people will try and state NPVs for the numerator. Remember, NPVs don't count for the numerator because the numerator can equal 0. It's just the bottom that can't. So first step, GCF difference of squares, which I can't do with a monomial. Step 2, state non-permissible values, which I've already done. Okay, now I'm done with them. Step 3, cross off anything that's the same. So this might be easier for you to recognize it if it's like this. So when it's a monomial like this, I can go 12, and x squared is just the same as writing an x and an x. And then the bottom, I have a 2. Sorry, I have a tickle in my throat. And an x. So, I can do 1-for-1 deal. This isn't like a 2-for-1 special. This is not Papa John's pizza. I don't even know if they have 2-for-1. I just tried being funny. Epic fail. Anyways, x and x cancel off. 1-for-1. And then I look at the coefficients. If they're just plain numbers in brackets, not something attached to them, but just a number, like a 12 and a 2. So there's just a number. I say, what can I take out of 12 and out of 2? So I can take a 2 out of 12 and a 2 out of 2. 12 divided by 2, I'm left with 6. 2 divided by 2, I'm left with 1. And I don't think I can cross off anything else. So I write what's left over. So I get 6x over 1. When I have 1 in the denominator, do I need to write it? No. When I have 1 in the numerator, I do have to write it. So I'm going to have 6x as my answer. I don't have to write the 1 in the bottom. And x cannot equal 0. My kids are playing on, I think, the PS4, PS something. I don't know. I'm not hip like that. But if you hear all that screaming in the background that I can hear, which I hope you can't hear, but I don't know if you can hear it, that's what they're doing. They're playing something. I don't know what it is. But they're okay. They're fine. They're having fun. Don't call anyone on me. Okay. B. So we look at B. And look, they're already factored for us. We have a plus 1 in its own brackets, so the a and the 1 are attached by plus sign, have to be in their own brackets. A minus 6 attached by plus minus sign, have to be in their own brackets. A minus 7 attached, a plus 1 attached. So I don't have to factor difference of squares, or GCF or difference of squares, because it's already done for me. So then I have to go to step 2, which is non-permissible values. So I have a minus 7 in brackets. So I'm going to say a minus 7 cannot equal 0. But I also have a plus 1 in brackets. So a plus 1 cannot equal 0. So I'm going to get 2 non-permissible values. All right. Blue it is. So a minus 7, I'm going to add 7 to both sides. And I'm going to get a cannot equal 7. And then this one I'm going to subtract 1 from both sides. I'm going to get a cannot equal negative 1. And then me being me, I like putting them together. It's just how I roll. So a cannot equal negative 1 and 7. All right. Now, when they're in brackets like this, guys, and I need you to pay close attention because I used to teach grade 10 all the time, and this was taught in grade 10 way back when it was old, pure, and applied. They used to teach us in grade 10, and then they taught in grade 11. Now in the new -1, -2 streams. And I see bad things happening, okay? When they're in brackets, and this is why I push brackets so much, the only way you can cancel them is if they match. Exactly. Everything inside the bracket. So a plus 1 and a plus 1 match, they can cancel off. But what do I get people doing? And I'm going to do this in different color because I'm going to erase it because it's that bad. I'm going to do it in red because red is dangerous. I did it over here, but I don't know why I used red. But anyways, I used red. So people will try and cancel off these A's. No, you cannot do that. The a minus 6 is attached as a whole entity. Let's pretend it's a person. Okay, a minus 6 and a minus 7. You just cut both their heads off. They don't count. It has to be the only way that an a minus 6. Okay, eraser. The only way that an a minus 6 and an a minus 7 are going anywhere is if I have an a minus 7 in the top. Do I have an a minus 7 in the numerator? Nope. So that a minus 7 is staying for life. I have an a minus 6 in the numerator. Is that going anywhere? Do I have an a minus 6 in the denominator to cancel off with it? Nope. So it's staying for life. So what is the error here? Often it's not undersimplifying. Often it's people go crazy with their simplifying and they cancel off stuff you can't cancel off. So this a minus 6 and this a minus 7 cannot cancel. So they're left. A minus 6. Oh, I'm in a dead zone on my iPad. A minus 6 over a minus 7. And then we get a cannot equal negative 1, comma 7, because we follow behind with our non-permissible values, just so they're all in one nice little neat spot. Okay, that's as good as it gets. Now, can I put brackets around these? Sure, absolutely. You can still leave brackets. But that is as good as it gets. You cannot cancel off those A's. Please do not cancel off those A's. You will be wrong if you cancel off the A's. So what am I saying? Don't cancel off the A's. Please, 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 please. Okay. C. We go to our numerator. So now we can take out some GCFs. So we're going to do that. So we're going to do numerators and denominators separately. So I have 8y plus 2 in the numerator. I can take a 2 out. When I take a 2 out of 8y, I'm left with 4y. When I take a 2 out of 2, I'm left with plus 1. Okay? In the denominator, I have an 8 and a y. Are they attached by plus or minus sign? No, they're attached by multiplication sign. So I can put them in their own brackets, an 8 by itself and a y by itself. Okay? I can't do any difference of squares because there aren't any. So that's step 1 done. GCF or difference of squares. The numerators and the denominators. Step 2, non-permissible values. So I take my brackets and I set them not equal to 0. Only the denominator ones though, right? So I go 8 cannot equal 0. y cannot equal 0. 8 cannot equal 0 doesn't get me an NPV. It's just correct. Y cannot equal 0 is my only non-permissible value. Then I say, can I cancel anything off? So people look at C and they immediately do this. They don't do GCFs and they go like this. You can't do that because the 8y and the 2 are actually attached by a plus sign, aren't they? So they're in their own brackets. Do I have an 8y plus 2 in the denominator? No, so I can't cancel it off. So remember that plus or minus sign attaches them. Please do not cross off right away. You would be wrong. Okay, so then I go 2 and 8. And I take a 2 out, and I'm left with a 1. I take an 8 divided by 2, and I'm left with a 4. Okay, so in the bottom I have a 4 and a y. Now people try and cancel off this 4y with the 4y in the numerator. But look at this. The 4y in the numerator is 4y plus 1. It is going nowhere unless there's a 4y plus 1 in the denominator. Is there a 4y plus 1 in the denominator? Nope. So you are done. 1 times 4y plus 1 is just 4y plus 1 in the numerator. And you can put it in its own brackets. And in the denominator, I have a 4 and a y. 4 and y are separate. 4y plus 1 is a whole thing. You cannot cancel those off. Please do not cancel those off. Follow behind with your non-permissible value. Y cannot equal 0. And we're done. Okay, D. For D, I have negative x plus 7, which I'm just going to leave for now because I can't take anything out of it currently. Negative x plus 7, I'm going to put it in brackets because it's attached by a plus sign. The bottom is a difference of squares. We have 49 minus x squared. Square root of 49 is 7. The square root of x squared is x. So I'm going to get 7 minus x, 7 plus x. Then I go to do my NPVs. So I go 7 minus x cannot equal 0. 7 plus x cannot equal 0. That's my two brackets. Then I'm going to add x over because it's the fastest way to get x by itself. So I'm going to get 7 equals x. And then this one I'm going to subtract 7 because that's the fastest way to get x by itself. So I get x cannot equal, not equal, negative 7. So I like putting them together. X cannot equal plus or minus 7. And if you notice with difference of squares, you get the same number with plus or minus 7. All right. Now, some people will say negative x plus 7 is not the same as any of the bottom. The catch is that the signs in front of the terms have to be the same. So this is negative x plus 7. This is negative x. This is a plus 7. So they're actually the same. So they cancel. Do you want to know what people will tell me the answer is? 7 plus x. But it's not. What was left in the numerator? A 1. Remember, you have to keep the 1 if it's in the numerator. So it's actually 1 over 7 plus x. So if your entire top, the numerator cancels off, you're left with a 1. And then you say x cannot equal plus or minus 7. Okay, let's look at E. So in E, the top, I can take a 4 and a p out of 12p squared minus 8p. So I take a 4p out. 12p squared divided by 4p is 3p. Minus 8p divided by 4p is minus 2. And the 4 and the p go in their own brackets. All over. 6p cubed minus 4p squared, I can take out a 2p squared. 6p cubed divided by 2p squared is 3p. Minus 4p squared divided by 2p squared is minus 2. And then the 2 and the p squared are in brackets separately because they're multiplied. Next thing I do is my non-permissible values, my NPVs. So I'm going to go 2 cannot equal 0, which is true, but not a non-permissible value. P squared cannot equal 0. And then 3p minus 2 cannot equal 0. How do I get p by itself when it has a squared? I take the square root. When you take the square root of 0, you get 0. You actually get technically plus or minus the 0, but just 0. And then we're going to add 2 to both sides. So I get 3p cannot equal 2. And then I'm going to divide by 3. P cannot equal 2/3. So p cannot equal 0 or 2/3 are my non-permissible values. Now I can go back and say, is there anything the same? Well, 3p minus 2 and 3p minus 2 completely match. 4 and 2 are both numbers just in their brackets, so can I take something out of both of them? Yes, I can take out a 2. 2 divided by 2 is 1. 4 divided by 2 is 2. And then I have a p and a p squared. Well, this one has 1p, this one has 2 p's. So I can cross off this one of these p's and this whole p. So in the numerator, I'm left with 2 over p. The rest all canceled off. And p cannot equal 0 or 2/3. Okay. For f, the bottom is already factored. The top, I can take a GCF of 3 out. When I take a 3 out, I'm left with t squared minus 25. And then on the bottom, I have t plus 3, t minus 5. The top is actually a difference of squares. This right here. Square root of t squared is t. The square root of 25 is 5. And I have a minus sign between. So on the top, I'm going to have 3 like I had before, but I'm going to end up with 2 factors. T plus 5, t minus 5. And in the bottom, t plus 3, t minus 5. And this 3 can go in its own brackets. All right. The t minus 5s cancel. Whoa! Can we cancel before we're stating NPVs? No, that's craziness. We have to state NPVs of anything that ever was there or is there. So before I cancel off, I have to state my NPVs always. So if I go to state my NPVs before I cancel, I'm good. If I go to state them after I cancel, slap my hand and be like, no, no canceling. You must state NPVs first. If you're wondering, I did slap my own hand for effect. So we get t plus 3 cannot equal 0. And we get t minus 5 cannot equal 0. And then we have to solve them separately. So I subtract 3. T cannot equal negative 3. I add 5. Usually I change colors. Sorry about that. T cannot equal 5. So those are my non-permissible values. Okay, now I can go back. T minus 5 and t minus 5 cancel. Some people will try and cancel off. I like there's a back button. This makes me happy. This 3 and this 3. Can we do that? No, because this is t plus 3. The only way it's going anywhere is if there's a t plus 3 in the top, and there is not. Then some people try and cross this t off with this t. Can you do that? No, because this is t plus 3. It's only going away if there's a t plus 3 in the numerator. This is t plus 5. It's only going away if there's a t minus 5 in the denominator. So there's actually nothing else you can do to this. You're going to end up with 3 t plus 5 over t plus 3. And your non-permissible values are going to be t cannot equal negative 3, comma 5. And that one's simplified. Okay? These ones here are your turn, so you're going to try them out on your own, following what we just did. So you're going to pause it and try them out, and then you're going to come press play and check and see if you got them right. So simplify the following rationals. So this is the monomial. When we have monomials, we just write them separately in brackets. We can skip step 1 of GCF and difference of squares. But I still have to state my non-permissible values. So my NPVs are going to be x to the 7 cannot equal 0. How do we get rid of x to the 7? We take the 7th root, which just makes it still 0, just so you know. So x cannot equal 0. If you don't know, you could type in your calculator. 7th root, 2nd root, 5th root, 8th root, 100th root of 0 is 0. So it's nice. And then we'd also have 36 cannot equal 0, but we know that that does not get us an NPV. Okay, then we go back and we say 18 and 36. What can I take out of both of them? Well, I can take an 18 out of both. 18 divided by 18 is 1. 36 divided by 18 is 2. And then on the top I have an x to the 4, and on the bottom I have an x to the 7. So x to the 4 I take 4 off. X to the 7 I take 4 off, so I'm left with x to the 3. So the entire numerator canceled. When the entire numerator cancels, I'm still left with a 1 over 2x3, followed by x cannot equal 0. All right. B. So we take a 3y out of the numerator. Pull it over here. And I take a 3y out. 3y divided by 3y is actually 1. So I'm still left with the number 1. Oops, touched my hand on the iPad. And then minus 9y squared divided by 3y squared. 3y is 3y over 6y cubed. The 3 and the y go in their own brackets. The 6 and the y cubed go in their own brackets. And my next step is to state non-permissible values. So I have 6 cannot equal 0, which is true, but doesn't get me an NPV. And then I get y cubed cannot equal 0. Take the cube root of 0, just like the 7th root of 0, and you get y cannot equal 0. All right, so now I see if I can cancel. I have a y and a y cubed by itself. I have a 1 minus 3y up here. Is there a 1 minus 3y in the denominator? No. So that 1 minus 3y is staying for life. Okay? Then I have a y and a y cubed by themselves. So I can take one y off of here and one y off of here, and I'm left with a 2. And then the 3 and the 6 are by themselves, so I can take a 3 out of both. 3 divided by 3 is 1. 6 divided by 3 is 2. So I'm left with 1 minus 3y on the top, and if you want to put in brackets, you can, over 2y squared. Y cannot equal 0. For C, it's a little more complex because I have to take out GCFs. So in the top, in the numerator of 3a cubed minus 3a squared, I can take out a 3a squared. I take a 3a squared out, I'm left with, out of 3a cubed, I'm left with 3, nope, no I'm not. I'm left with a, and then negative 3a squared divided by 3a squared is minus 1. And then the 3 is in its own brackets, and the a squared is in its own brackets. In the bottom, I can take a negative 12 out. Negative 12a divided by negative 12 is a. And then 12 divided by negative 12 is minus 1. Go do my NPVs. I have negative 12 cannot equal 0, which is true. Doesn't get me an NPV. And then a minus 1 cannot equal 0. Add 1. A cannot equal 1 is my NPV. And then I cancel. So a minus 1 and a minus 1 completely match, so they can go away. A squared in the top but nothing in the bottom, so the a squared staying. 3 and negative 12, I can take a 3 out. 3 divided by 3 is 1. And negative 12 divided by 3 is negative 4. So in the numerator, I'm left with a squared over the denominator, which is negative 4. A cannot equal 1. All right. So I will be filling in example 2 and the your turn. I'll be filling them in on the notes. So if you want to try them out, you can go check the notes and see if you got them right. Okay, because they're just extra practice for what we just did. But I'm going to flip over to the last page. So these will be filled in on the filled in notes section. You can go check and see if you got them right, but I'm not going to go through them on the podcast. These ones I want to go over because they're just a little bit different. Oh my gosh, I'm having problems. Okay, so this is the last example. So like I said, example 2 in your turn, you can go on the notes, filled in notes, and they'll be there so you can check them if you want to do them. But we're going right to this one because they're just one little catch of taking out a negative sign so you can get factors to match. All right? Okay, so we have C minus 4, and we have 4 minus C. I can't take anything out of either of them. They're attached in brackets because they're attached by minus signs. They do not match because the top is positive C minus 4 and the bottom is positive 4 minus C. Okay? They don't match. But if I took a negative 1 out of either of them, it would change the signs in the brackets and they would match. So if you get a factor that matches in the numerator and denominator with the sign and the with the number and the variable, but the signs are opposite. So in this case, positive C and minus 4, and in the bottom, positive 4 and minus C. You can make them the same by taking negative 1 out of one of them. Okay? So I'm going to go in the top, C minus 4. And in the bottom, I'm going to take a negative 1 out. And when I take a negative 1 out of 4, I get negative 4. Take a negative 1 out of negative C, I get positive C. And now they're going to actually match. So I can rewrite the bottom and go C minus 4 in the top. And in the bottom, I can write negative 1, and I can rearrange this term. I can go positive C minus 4 because I take the sign that's in front of the term. And now they actually match. But before I cancel, I have to state my NPVs. So I have negative 1 cannot equal 0, which is true, but not a problem. And I have C minus 4 cannot equal 0, add 4. C cannot equal 4 is my non-permissible value. Now, the C minus 4 and the C minus 4 cancel. So the entire numerator canceled, so I'm still left with a 1 up there. So 1 over negative 1, which is actually just negative 1. And I have to follow behind with C cannot equal 4. For B, take out my GCF, or difference of squares. So let's see. The top I have 2p cubed minus 4p squared. So I always see, can I take out a GCF? And I can. I can take out a 2 and a p squared. So I take out a 2 and a p squared. 2p cubed divided by 2p squared is p. Minus 4p squared minus 2, or divided by 2p squared is minus 2. And then the 2 and the p squared are in their own brackets. On the bottom, I have 16 minus 8p. So I can take out an 8. When I take 16 divided by 8, I get 2. Minus ap divided by 8 is p. Now if you look at, let me get a red out here. This is positive p minus 2. This is positive 2 minus p. So they're the exact same, 2 and p, but wrong signs. So what I should have done is I should have taken out a negative 8. Then this would be a negative 2, and this would be a positive p, and now they'll match. So in reality, I should have 2 p squared p minus 2 over negative 8 positive p minus 2. State my NPVs. Negative 8 cannot equal 0, which is true, but not an NPV. P minus 2 cannot equal 0. Add the 2. P cannot equal 2. Cancel off the p minus 2's. P squared has to stay. I can take a 2 out of each of these. So this gets me a 1. This gets me a negative 4. So I'm left with p squared over negative 4. Don't know why I made that line so big, sorry. And then p cannot equal 2. 2 more left. So these are all ones where you have to take out a negative in order to get them to match. So you can try this one out on your own. Pause it. All right. So 25 minus x squared over x minus 5, 2x plus 1. So 25 minus x squared is actually a difference of squares. If I take the square root of 25, I get 5. The square root of x squared, I get x. And there's a difference, there's a subtraction sign in between. So I'm going to get 5 minus x, 5 plus x. Over x minus 5, 2x plus 1. Okay? Now if you look at these two, I have positive 5 minus x and I have positive x minus 5. So what I should do is take a negative 1 out. That'll change this to a negative 5 and this to a positive x, and now they'll match. So I'm going to get negative 1, positive x minus 5. I can rearrange that first bracket. 5 plus x, I can rearrange to x plus 5 if I'd like. Then on the bottom, I have x minus 5 and 2x plus 1 in brackets. So I do my NPVs, and I'm going to get x minus 5 cannot equal 0, and 2x plus 1 cannot equal 0 because I only state non-permissible values as the denominator. I'm going to add 5 to both sides. X cannot equal 5. Here I'm going to subtract 1. 2x cannot equal negative 1. Divide by 2. X cannot equal negative a half. And then I go back once I state my PVs and I say x minus 5's are the same, so they cancel. Nothing else can cancel because they're not the same. So I get negative 1, x plus 5. Wow, I'm doing a rainbow of color on this question. Over 2x plus 1. And then x cannot equal 5, negative a half. One more left. 2p squared minus 128 over 16 minus 2p. So this is one of the hardest ones I could give you, so we did it last. On the top, I can take out a 2, and I'm left with p squared minus 64. Over, on the bottom, I can take out a 2, and I'm left with 8 minus p. Okay. This p squared minus 64 is actually a difference of squares. The square root of p squared is p. The square root of 64 is 8. So I'm going to get 2 in brackets, and then p plus 8, p minus 8. And on the bottom, I have 2, and I have 8 minus p. So if you look at these, I have positive p minus 8. Here I have positive 8 minus p. I need them to match. So I'm going to take a negative 2 out of the bottom. You could take it out of the top or the bottom. I'm just choosing to take it out of the bottom. So I have a negative 2 in the bottom, so this can become negative 8 and positive p. So what I'm actually going to get is 2, p plus 8, p minus 8, over negative 2, positive p minus 8, because it's negative 8 plus p. Okay? So, I'm going to do my NPVs next because I have to do them before I cancel, and I always catch myself sometimes trying to cancel before because I see things that match and they make me super happy. So negative 2 cannot equal 0 is true, non-NPV. P minus 8 cannot equal 0. Add 8. P cannot equal 8 is my non-permissible value. P minus 8's cancel. and the 2's cancel. So 2 divided by 2 is 1. 2 divided by 2 is -1. So I'm left with p plus 8 over -1. And what you can do when your whole entire numerator is just over -1 is you can actually apply it to the top and it changes all the signs and goes away. So if you left it like this, for me, I'd be happy. But that -1 can actually go to the top and you can get -p minus 8. And it can only go to the top because it's just a -1 on the bottom. If there was more, you wouldn't want to do that. You just leave it in the bottom. Ooh, I just forgot my NPVs. And p cannot equal 8. And that's it. That's all for this lesson. That is simplifying rationals, and you should be happy because, like I said, it does not have trinomial factoring, which is super exciting. I hope you have a great week, and I hope you still find that inner being that gets yourself to work and try hard and put in the effort. I know it's not easy in May, as it is, but you got to dig deep and try and get through this, because all you have left is 4 weeks. And after this lesson, you have left 3 weeks, okay? So you can do it. So the next 2 weeks after this are new lessons, and then the last week is a review to replace your lowest online assignment. Have a great weekend.